Hello, today we are going to discuss generalized coordinates. So, before entering into generalized coordinate, we need to discuss on fundamental information. For example, if you consider a particle of mass m moving with velocity, so we need to describe this particle. Um, if we need to find the position with respect to time, then we need to describe this. We need a one Cartesian coordinate system. So that is a general Cartesian coordinate system. Or if you consider a particle is moving in a plane, so we need to describe motion of the system. We need a plane polar Cartesian coordinate system. This one, okay. Next, in case particle is moving on surface like a cylinder or spherical body, cylindrical body, we need two different type of Cartesian coordinates. One is cylindrical, another one is a spherical coordinate system. So these are the known Cartesian coordinate system to describe the motion of the particle general. So there is another type of coordinate systems are introduced by the Lagrangian, so that is called the generalized coordinates. So before entering into the generalized coordinates, let us look to some significant importance in the field of classical mechanics and physics for several reasons why we are uh, choosing these generalized coordinates. What are the importance role for generalized coordinates? So first, simplified description. Generalized coordinates allow complex mechanical systems to describe using a reduced set of independent variables. This simplification, the mathematical formulation of the systems, dynamical systems, to reduce the complexity of the equations of motion, making an analysis more manageable. This is one of the advantages. Next, handling constraints. When the constraints are present in a system, then can make the use of Cartesian coordinate systems, generalized coordinate systems provide a natural way to incorporate constraints and simplify the equation of motion, making it easier and account for the system's behavior. While satisfying the constraints, the third most important point, efficient in the equation of formulation. The equation of motion derived using generalized coordinates known as Lagrangian's equations or Euler-Lagrangian equation, or we can call sometimes Euler-Lagrangian equation of the more compact element compared to the equivalent equation derived using the force and acceleration. This efficiency simplify the calculation and facilitate the identification of the pattern and the symmetry of the dynamical system. So third most important point, flexibility in a Cartesian coordinate choice. Choice of generalized coordinate system is not unique, can be tailored to the problem at handing. This flexibility allows one to choose the coordinates and particularly suited to describe the dynamical system motion, leading to the more intensive equations better than the insight into the system's behavior. Fifth most important point is the handling the high dimensions generalized coordinates enable the analysis of the system with the high dimensions. Cartesian coordinates can be quickly may become a unwieldy in the high dimension space, whereas the proper choice set of coordinate systems can be simply representation of such systems. Sixth most important point, versatility in the various fields. The concept of the generalized coordinates is not a limit to the mechanics alone. It's fundamental idea that find applications in various fields like physics, engineering, and robotics, and even solving complex mathematics. problems involving the multiple variables. These are the very very important uh, steps described by the uh, Lagrangian. So, the most important point is symbolic and numerical analytic or numerical analysis. Generalized coordinates are particularly useful to symbolic nature. They allow formulation of equation of motion in terms of symbolic variables. So, facilitating the symbolic manipulation and solving more numerical analytic techniques can be applied more effectively to the systems to describe using the generalized coordinates. So, eight most important point is the exploration of the physics uh, principles, generalized coordinates, enable to explore the various physical problems such as the conservative laws, symmetries, energy transformation in more straightforward, the intentive manner. They help identify pattern and relationship that might not be as appeared in Cartesian coordinates. So, which is why we are choosing um, generalized coordinates instead of the Cartesian coordinates. So, in essence, the generalized coordinates proved a powerful tool to describe, analyze complex mechanical systems and physical phenomena. They offer efficiency and flexibility and more generalized formation equation make them the cornerstone of classical mechanics and variable concept across the various scientific and engineering disciplinary systems. So these are the generalized coordinates important steps and points. Uh, the name generalized coordinates given by set of independent coordinates. So these are the set of independent coordinates. Remember to describe the complete state of configuration of the dynamical systems. These coordinates are denoted by Q1, Q2, Q3, and so on, Qk, Qn. So then this set we can call this 3n degrees of freedom, where n is the total number of generalized coordinates. This n, okay, this n, Qn, right? Total number of generalized coordinates. In fact, the minimum number of coordinates needed to describe the system. So let us look at some examples of generalized coordinates. So first we need to look, for example, a particle constrained. So this is particle. This is constrained to move on the circumference of a circle only. This is the constraint. So how many generalized coordinates needed to describe this system? So if this won't move, this is circle, right? Which means this r is a constant. Okay, and then it will vary only the angle theta, right? So if you look at this one, we need only one generalized coordinate to describe the motion of the system. So let us look another example for a particle moving surface of the sphere. So this is sphere. So this particle moving surface of the sphere. This is a circle. Okay, this is sphere. So this particle will move in this way, like this. So we need one, and one more thing is there. This particle will move like this. So we need two generalized coordinates to describe this system. So if we look at this first one is, I mean, this is first one. So this is the theta, first generalized coordinate, and second one, this one. This one is the pi. So we need two generalized coordinate to describe this type of system. So suppose the generalized coordinate for a system of n particle. So for example, we have n particle is said. So constraints by the equation m. So we need 3n minus m generalized coordinates. Okay. So if you look at the simple pendulum, so it's moving like this. Okay. Then we need only one generalized coordinates to describe the motion of this simple pendulum. So these are all the generalized coordinates. So very important concept. By using these generalized coordinates, we can describe the motion of the system easily instead of Cartesian coordinates systems. Thank you.